Students, now we come to lecture 15, knocking in CI engines. Now, to understand lecture 15, you must have read lecture 14, in which the 4 stages of combustion in CI engines were discussed. And unless you've seen that, you will not be able to understand this lecture. So, it's recommended, go through lecture 14, then only you will make out. Lot has been repeated also. Now, having seen the stages, 4 stages in compression ignition engines, let us study the knocking in CI engines. Now, during the period of uncontrolled combustion, the fuel already injected during the delay period burns rapidly. This we have studied last time, the last lecture. The rate of this burning determines the rate of pressure rise in the cylinder. Seen in the last lecture again. A high rate of pressure rise means a sudden increase in the load on the engine structure, which may damage the engine parts. It may also produce a violent pounding noise called knocking. Now, all this was covered in the previous lecture while studying the period of uncontrolled and controlled combustion. Since knocking in CI engines can have the same damaging effect as detonation in spark ignition engines, petrol engines, it is important to eliminate it altogether. We must eliminate knock altogether because, as you can see, what damage it can do. Knocking is due to, this is again repeated, knocking is due to high rate of pressure rise during the period of uncontrolled combustion, which in turn depends on the delay period. This we had covered extensively in lecture 14. Larger the delay period, higher the rate of pressure rise, because when the delay period is, as we studied in the lecture 14, delay period is larger, there will be more fuel, and therefore the pressure rise will also be higher, and higher the knock. Consequently, the knock will also be higher. Therefore, thus, to avoid knocking in CI engines, it is desirable to have as low a delay period as possible. In CI engines, the delay period should be kept as low as possible so that the peak pressure does not rise too high in the cylinder, which goes on to develop knocking. Now, we had studied detonation and knocking in the spark ignition engines. So, related to the two knockings, let us look at this important note. That was covered, I think, in lecture 13, the knocking and detonation in spark ignition engines. It will be seen that delay period should be large enough in case of spark ignition engines, which we studied in lecture 13, while in case of compression ignition engines, the delay period should be small as possible so as to eliminate the effects of detonation and knock in the 2 cases respectively. Thus, what do we learn from this sentence? Thus, the measures to be taken to control knock in CI engines are just reverse of those required to suppress detonation in spark ignition engines. So, the measures to be taken are reverse. In one, you require a larger delay period, in the other, you require a shorter delay period. This all we had covered in the previous 2-3 lectures. Now, in spark ignition engines, we had studied the octane number, and there also I had mentioned that for diesel fuels, diesel-based fuels, it is the cetane number. We've given a short form, the CN. Now let us understand the cetane number of diesel fuels. Self-ignition property of diesel is desirable. We had mentioned in the last lecture that self-ignition temperature of diesel is approximately 350 degrees centigrade in high-speed CI engines. Self-ignition property of diesel is desirable in high-speed CI engines. The higher the cetane number, the more suitable. If an engine runs on a fuel with too low a cetane number, there will be diesel knock. So the cetane number should be as high as possible. A lower one will cause knock. Now let us define CN. What is the CN? The definition. You've understood what a low and a high CN can do. Now let us see what is CN. Definition of CN. Cetane number of a fuel is defined by finding a blend of cetane and heptamethylnonane with the same ignition delay. Both should have the same ignition delay. Both these chemicals mentioned. Cetane has a cetane number defined to be 100, while isocetanes measured CN is 15. Cetane is 100, isocetanes is 15. Replacing, this is recent, earlier it was something else, replacing the former reference fuel alpha methyl naphthalene, which was assigned a cetane number of 0. This is gone, this is history, now it is this one, 15. Once the blend is known, once the blend between the two is known, the cetane number is calculated as a volume weighted average, rounded to the nearest whole number of cetanes 100 and heptamethylnonanes 50. So it's a combination of the two. So we can give an equation to this. So, what is the equation? The cetane number is equal to the percentage N cetane plus 0.15% of heptamethylnonane, which we just read on the previous page. So this is, could say, the definition of cetane number. It's a mixture of the two. Typical values of cetane number. Generally, diesel engines operate well within a CN from 48 to 50. This is the one which you get in our filling stations all over our country, 48 to 50. Fuels with a lower CN, if it's below this, have longer ignition delays, requiring more time for the fuel combustion process. Lower ignition delays, ignition delays process to be completed. That means the combustion will take place longer. So, in the case of lower CN fuel, hence higher speed diesel engines operate more effectively than higher CN fuels. The premium diesel fuel which is marketed by our companies, Indian Oil, Bharat Petroleum and all that, is costlier, called premium fuel. Speed is also one name is given, speed. Premium diesel fuel can have a cetane number of up to 60 also. This is 60. Now, besides the CN number, you can also add additives. We had seen the additives in the case of the petrol engines. Octane number it was called, and we had mentioned there what are the additives used to improve the octane number. Here also additives are used in diesel. Additives in diesel fuel to improve the cetane number. As we mentioned, the cetane number should be high, should not be low. To improve the cetane number are referred to as ignition accelerators. They are referred to as ignition, technical name is ignition accelerators. We want the ignition to take place quickly and not delayed. Typical ones used are alkyl nitrates, and the second one is ditert butyl peroxide. So this covers the knocking and octane and cetane numbers of CI and SI engines. The next, as per our syllabus, is the design of combustion chambers. We will individually see the design of combustion chambers of petrol and then of diesel engines. Thank you.